Hi all, and thanks for tuning into this year's virtual Georgia Water Resources Conference. I'm Kyle, a graduate student at the University of Georgia's Odom School of Ecology, and today I'll be talking about some of the work we're doing in Athens-Clarke County regarding septic tank maintenance and repair patterns. So in the U.S., about 1 in every 5 Americans rely on an on-site wastewater treatment system to safely dispose of their wastewater. In Georgia, that proportion is even higher, with half of the population, or approximately 5.7 million Georgians, relying on decentralized wastewater systems. In the Southeast U.S., the trend of decentralized wastewater treatment is likely to remain prominent in some areas into the future, as this region of this nation is currently undergoing a rapid rate of population growth and commensurate residential development in urban and especially suburban areas. And those areas are outside the central sewer networks of many cities and thus necessitate on-site wastewater treatment. Additionally, decentralized wastewater treatment will likely remain an attractive alternative for municipalities going into the future. As we see in these pictures, the process of installing sewer lines really has not changed much in the 100 years or so that we've been installing this infrastructure. It's still a very disruptive and costly process. And in addition to the costs that are incurred during the installation of new sewer networks, municipalities also have to continually ensure that these systems are functioning properly and repair them when they do eventually fail. So traditionally, when people refer to on-site or decentralized wastewater treatment, they're referring to a conventional subsurface septic system. These are comprised of 3 primary components, the first being the septic tank, which holds the biosolids and should be pumped out every 3 to 5 years as per the US EPA's recommendations. The second component is the drain field, which receives liquid effluent from the septic tank and distributes it. And the final part are the soils. These rely on biogeochemical processes to filter and neutralize wastewater constituents before the water connects to subsurface groundwater or potentially our streams and rivers. So with these systems, given the correct siting and maintenance intervals, they've been shown to work effectively, and they've become a viable option for local governments and are attractive due to their low incurred costs. They're also popular with homeowners, as after installation, there's little, if any, oversight or forced regular costs. In essence, these homeowners avoid a monthly sewer bill. However, for some of these same reasons, septic systems can be vulnerable to failure. This could be due to a number of reasons, including being installed on imperfect sites that can't absorb and treat wastewater, or the homeowner may simply choose not to maintain their system adequately. And this results in systems only being repaired when they catastrophically fail. So in thus far, we've established that septic systems rely both on spatially heterogeneous biogeochemical processes, as well as proper maintenance to safely treat wastewater. However, little is known about how these components might interact to predict where systems are failing on the landscape. Therefore, we integrated both widely available spatial data and a novel countywide data set to assess where and when septic systems are maintained or repaired. And to do that, we asked a number of questions, the first of which looked at relationships between tank age, tank site characteristics, and a binary response of whether the county had repair records on the tanks or not. Secondly, we looked again at tank age and tank site characteristics, but this time whether the tank had been pumped at all in a 3-year period of record. And finally, we conducted a similar analysis using anomalous pumping records, which we think might be indicative of failing tanks that may be in need of repair soon. And to do this, we used logistic regression, which is a type of generalized linear model which lends itself well to data sets with binary presence or absence observations, like we have in our case. And to assess our top models, we use either the Bayesian or Ahiki's information criterion, depending on the sample size that was used to assess each of our sub-questions. And similar methods have been used to assess water main failures, as we see in the pictures on top, as well as sewer line failures, as we see in this graph below. Here in Athens-Clarke County, about 75% of residents are serviced by the central sewer network, which we see here in the orange, blue, and green polygons on the map. That means another 32,000 residents rely on approximately 9,000 individual septic systems to treat their domestic wastewater, which are indicated by the gray dots. And the Athens local government's GIS and public utilities departments have developed and maintained an excellent geospatial data set of septic system locations here in the county. With those data, we not only have the repair records of whether those systems have had any work done on them, but even more recently, we've been able to associate those locations with their pumping history and thus are able to get dates and volumes of the septage that was removed from those septic tanks. For those tanks that we have pumping records for, we subset them further into tanks that display pumping behaviors that are indicative of failing systems. And one way we did that is to look at the frequency by which each tank was pumped in our 3-year data period. During that time, we might expect a normally functioning tank to only be pumped once, as the homeowner has little, if any, incentive to maintain their tank more than what's necessary, which is usually one pump in every 3 to 5 years. Additionally, because we have the pumped volume, we could compare that to what the county actually has on record as the tank capacity. And thus, we're able to identify tanks where that volume is exceeded and that are likely flooding or have not been pumped in a very long time. For predictor variables, we used various combinations of data that may drive these systems to exhibit certain repair or pumping patterns that include the soils that they're situated on, the system age, their distance to stream and thus possible exposure to being inundated, and an index of predicted site wetness based on nearby topographic characteristics. And now I'll go over some preliminary results, and just a note that we haven't accounted for spatial correlation in these models. As such, some of our model estimates may be a bit different from our final analysis. And likewise, covariates that are nearly significant may not be after accounting for spatial autocorrelation. So for systems with repair records, we found that the models, which included age and distance to stream, were our top performing models. And using that information, we were able to plot a probability of repair curve for those systems, which we see on the right-hand secondary y-axis, per system age on the x-axis. Regarding our analysis, looking at a binary pumped, not pumped response, none of our models were able to capture the pattern of whether they had been pumped over our period of record. That's not particularly surprising because a lot can influence if a homeowner chooses to get their tank pumped, such as their socio-economic status, or maybe even their knowledge that they have a septic system. Similarly, with that subset of tanks with pumping records, we were not able to predict those tanks that were frequently pumped, or in other words, pumped more than once in our 3-year data period. However, for the pump systems that had volumes which exceeded the total capacity that the county had on record, we found that tank age and the square of the tank age predicted this response well. And we again developed a plot to predict the probability of a volume exceedance on the y-axis over tank age on the x-axis. And this bimodal or two-humped response is quite interesting as it indicates that either quite young tanks or old tanks have a higher probability of pumped volume exceedance. For young tanks, this may suggest that the systems are located on inadequate soils, poorly installed, or the soil environment is still coming to an equilibrium during this phase and has a lower water acceptance rate, or some combination thereof. Finally, looking at whether a tank exhibited either overpumping frequency or volume exceedances, we ended up with two top models. Again, the age and quadratic age model performed well as age and distance to stream. And likewise, we developed a probability of either volume or frequency exceedance patterns for those tanks, which looks very much like the volume exceedance curve we saw before. For future work with these data, I'd like to continue to look at those units that we have repair records for and analyze their prerequisite pumping patterns. In that way, we may be able to identify three mechanisms by which tanks eventually fail and need repairs. The first being, if they have no pumping record, it may indicate that they've simply been unmaintained. Secondly, if they exhibit normal pumping behaviors or just one pump in that 3-year period, it may be a sign that the site is inadequate or simply that the tank is getting old. And finally, if they exhibit those anomalous pumping patterns, it may be acting as a sort of early warning system that something isn't right and that the unit may eventually fail and need repairs. We're also quite interested to see whether incorporating socio-demographic data at the census block level or even parcel level data would help further explain some of the patterns we're seeing in these maintenance intervals. And just a side note that Athens is a particularly interesting location to be conducting such research due to the relatively high proportion of the population that's below the poverty line. So in this study, we were indeed able to show that older tanks were more likely to be repaired. And that might seem obvious, however, there's a marked lack of quantitative data supporting that assumption in the literature. Likewise, by identifying the characteristics of tanks with some anomalous pumping patterns, we showed that either very young or old tanks display unique pumping signals. And that's very important information to know about because we really rely on these systems to keep our communities and our environment healthy. And lastly, this analysis can help guide data collation in localities with less robust data on their decentralized wastewater systems. In summary, on-site wastewater treatment will likely remain an affordable and usually effective wastewater treatment option in residential areas on the periphery of central sewer networks. The decentralized nature of these systems are attractive for several reasons. However, it also means that their performance across the landscape is heterogeneous. The county's data set that we're working with is also quite unique and has already provided some insights into how these systems are repaired and maintained. And finally, our findings could be used not only in Athens-Clarke County to prioritize wastewater infrastructure, but could also be applicable more broadly as well. Lastly, I'd like to acknowledge the hard work and dedication of a long list of folks that have contributed to this body of work. I'd also like to acknowledge the support I've received from the University of Georgia's River Basin Center through my funding. With that, I thank you for watching. I hope you learned something and would gladly field some questions at this moment. Thank you.